Okay, dear student, today we will start with the capacitor. So before starting the capacitor, first we should know the certain basic idea about the charge and potential, how the potential changes when we are giving a charge to a conductor. So see, when a charge is given to a conductor, its potential increases. Its potential increases. Q is the charge given to a conductor and V is its potential. V is its potential, then Q is proportional to V. And when we are removing the proportionality sign, so we will get one constant. So where C is constant, known as proportionality constant, or it is also called capacitance of a conductor. So from here we can say C is equal to your Q by V. So first of all, what is the meaning of a capacitance? Capacitance of a conductor means the capacity of a conductor by which it can store potential energy, as well as we can say it can store a charge on it. So it is simply depends on the geometrical shape and size of a conductor. There are so many factors on which capacitance of a conductor depends. So this can be written in other form is like C is equal to Q. V can be said as we know in the previous chapter we have studied, V can be written as minus E dot dr, and the value of E dot dr between, we can say, from surface to infinity. This is another way of representing capacitance of a conductor. From this expression, we cannot say the capacitance depends on charge and potential. Actually, capacitance is, as it is written here, proportionality constant. It means the ratio of charge with a potential on it, that give you the capacitance. It is similar to the, as we have read in case of Ohm's law. In Ohm's law, what we found, V is equal to R into I. So V into Ri, so R we can say V by I. So it does not mean that our resistance depends on potential as well as current. So that resistance is just like a proportionality constant which relate potential with a current. Similarly, C is the capacitance, and that relate charge and potential on a conductor. So it does not depends on the charge on a conductor as well as potential on it. It depends on other parameters just like a geometrical shape and size of a conductor. So we will write about these certain points. So first point we can say capacitance is a scalar physical quantity capacitance is a scalar physical quantity its SI unit is from here we can get SI unit coulomb per volt coulomb per volt, or it is also called as farad. And normally we are representing farad with a capital F. So its SI unit is coulomb per volt, or we can say it is farad, and its dimension is given as dimension of C. From here, there is dimension of charge by dimension of potential, and dimension of potential further we can say W by Q. It will be your Q square by work done, and dimension of charge is A T. So Q square means it becomes your A square T square by dimension of work done is M L square T minus 2. So finally we can say dimension of capacitance is written as M minus 1 L minus 2 A square and T to the power 4, like this. Now the second point. Capacitance of a conductor depends on geometrical shape and size of conductor. Depends on geometrical shape and size of conductor. So it also depends on geometrical shape and size of conductor. Normally it has been found that the bigger as the conductor, its capacitance is more, and it also depends on the which type of shape conductor have. Similarly, third point, capacitance of a conductor depends on surrounding medium. Capacitance of conductor depends on surrounding medium. So meaning of that, when a conductor is kept in a medium, so it depends on surrounding medium. Is how it depends on surrounding medium. When we are giving a charge to a conductor, so its potential increases, as well as we can say its electric field also increases. So when that electric field passes through the surrounding medium atom molecules, so all the medium molecules or atom have certain strength. Certain strength means they can ionize as we are increasing the electric field. So it depends on which type of medium we are having. The medium which ionized earlier, so our capacity of that conductor will be less, and those medium which cannot ionize, even if we are supplying much more amount of charge or much more amount of electric field, so for those type of medium we can put much more charge on a conductor, so our capacity will increase. So for example, we can say as compared to the non-conducting medium and conducting medium, if we are comparing with these two medium, so in case of non-conducting medium, our capacity of a conductor will be more as compared to partially or fully conducting medium. It means if surrounding medium is non-conductors, we can give much more amount of charge on a conductor, because this, in case of non-conductor, much more amount of electric field needed to ionize the molecule of a non-conductors. So these are the major factors on which the capacitance of a conductor depends. The first of them, we can say the capacitance of a conductor depends on geometrical shape and size of conductor. Second point, capacitance of a conductor also depends on surrounding medium. So when the medium is your insulators or non-conductor, then its capacitance increases. So we can write when surrounding medium is insulator or non-conductor, then capacitance of a conductor will be more. Capacitance of conductor will be more as compared to partially or fully conducting medium. So these are the main factors on which capacitance of a conductor changes. Next point. Now calculation of capacitance. We will use the basic formula C is equal to your Q by V or Q by E dot dr. This is the basic and fundamental relation by which we can get the capacitance of a conductor. So here V is nothing, it is the potential. Potential on the surface of conductor means potential difference from the surface to infinity. Likewise, see, first case, capacitance of a spherical conductor. Capacitance of a spherical conductor. Suppose this is a conductor of radius r is given. Now if we want to find what is the capacitance of this, so what we can say, it is not necessary the conductor must have a charge. Only we are assuming. Assuming means suppose if we are giving a charge Q, so because of that charge Q, how much the potential develop on its surface. So ratio of charge with the potential, that is called your capacitance. See, so let Q charge given to conductor. Q charge is given to the conductor. Then we will calculate the potential on its surface. Then we will calculate potential on its surface with respect to infinity. See, if Q charge is given to this conductor, that this is charge Q. Then if we would like to calculate the potential, so either we can use this is nothing, meaning of that the potential difference between surface to infinity. So dV is equal to your minus E dot dr. So what we will do, we will take any point P at distance r from the center. At that point we will write the electric field. So 1 by 4 pi epsilon naught Q by r square, and this is small distance dr. In this dr distance, change in the potential written as dV to dr. Then integrate. When we are integrating, so limit of integration from surface, we want from surface. From surface means small r is your r, capital R. Then the V will be your V on surface. And infinity, at infinity we are assuming it is the 0 value. So this will come 0 minus V on surface equal to your 1 by 4 pi epsilon naught Q by infinity minus Q by R. So finally we will get, so finally from here we can get V on surface equal to 1 by 4 pi epsilon naught Q by R. So this is V on surface. So according to our this result, the C can be written as Q by V on surface. So this will be 4 pi epsilon naught R. So capacitance of a spherical conductor is written as 4 pi epsilon naught R. Now same question here. If we are making a surrounding medium, let have dielectric strength K. Now that we can extend the another medium C. If surrounding medium have dielectric strength K, then capacitance C. Same method. It means this medium have dielectric constant K. Then what will happen here? In the same expression, as we know, if the medium is other than the vacuum or air, then the electric field is written as 1 by 4 pi epsilon naught K Q by R square. So another factor here, K will come here. So in the whole expression, K will come here. So we can write C in the medium is written as 4 pi epsilon naught K into R. So from here we observe as K value is greater than 1, so we can say capacitance in a surrounding medium of dielectric constant K is more than the capacitance in vacuum or air, as we told you or as I have suggested you in the previous, capacitance depends on the surrounding medium. So in place of air or vacuum, if any non-conducting medium is kept, so for that capacitance will be more than the compared to the capacitance in air. Similarly, capacitance depends on the geometrical shape and size. It means radius of the conductor. As radius of conductor increases, so capacitance also increases. So bigger size of conductor have more capacity as compared to a smaller size of conductor. Similarly, now if conductor is earth, then capacitance. It means this conductor is given and it has been made earth. So what will happen in that case? After earthing, the potential of this conductor is always 0. Potential of this conductor is always 0. If theoretically we are talking about capacitance, so as V0, the C will be your infinity, because as V is your 0. The C infinity means its capacitance infinity. The capacitance infinity does not mean it can store infinite amount of charge as well as infinite amount of energy. The simple meaning of that is whenever giving a certain charge on it, so that charge through this wire will go to the earth. So whatever extra charge we are giving, that charge will go in that manner. It can take infinite amount of charge. It is very similar to that if we are talking about what is the capacity of a glass. and if a small hole has been made here, so whatever the amount of water we are giving into the glass, that amount of water will leak out, so it will never fill. Never fill means we can say it can take infinite amount of water to become a fully filled. This and this are the similar meaning. It can take, or the glass can take infinite amount of water, then also it will never fill. Similarly, the capacitor or conductor can take infinite amount of charge, then also it will never fill, because all the charge will come out from the surface to earth. So practically there is no meaning of capacity infinity. Only theoretically we can say capacitance of the conductor, earth conductor, is your infinite, but practical there is no sense, no purpose of that. Now come to the next point. Now energy is stored by a charged conductor. Energy is stored by a charged conductor Suppose this is a conductor having certain charge Q and its capacity is your C. Okay, Q is a charge on conductor and C is the capacitance of conductor. Capacitance of conductor. So first thing is that how the charge has come and how it store energy. In normal condition, all of the conductors are neutral. Neutral means they don't have any excess electron or deficiency in the electron. So when we are calling or saying the conductor is your positively charged, it means some of the electron has been taken out from the conductor. The sum of the electron has been taken out. So simple meaning is that when we are removing the electron, so this conductor become a positively charged and that positively charged conductor attract electron. So we have to apply some extra force to pull those electrons from surface to infinity. In that manner, whatever work we are doing, that work is nothing. The energy is stored in a conductor in the form of potential energy. So in that manner, whatever work we have done to make this conductor as a charge conductor of charge Q, so that energy or that work is called your energy stored in conductor. Then how to calculate? See, as we know, work done is given as change in potential energy is equal to work done by external agent against electrostatic force. Now let at any time Q is the charge and we are removing dq charge. So when charge is Q, at that time let potential your V. So du is equal to your dw and this written as V into dq. So when V is the potential and we are removing dq charge and V further written as we have done in the previous case, V is equal to your Q by C into dq, as C is equal to Q by V. From that we can write V is equal to Q by C. So total energy written as du is equal to 1 by C Q dq. Then we can integrate from 0 to total charge Q. So U is equal to half Q square by C. This is the amount of energy stored in a charged conductor. And this expression further can be replaced in another term, half, as C is equal to Q by V. If we want to write in terms of C and V, the Q is equal to CV square. So this can be written as Q is equal to half CV square, or Q by C we can write V, so half Q into V. These are all the expression related to energy stored by a charged conductor in terms of capacitance of a conductor. Now, the same formula or same relation we can use. Let if conductor is spherical, if conductor is spherical and its radius r, like this. This is your spherical conductor, radius r, and let it has charge q. And then we are talking about how much energy is stored. So energy stored by a conductor is written as half, q is the charge, and capacitance already we have determined for a spherical conductor, that is your 4 pi epsilon naught r. So this become your q square by 8 pi epsilon naught r. So spherical, so energy stored by a spherical conductor of radius r is given as q square by 8 pi epsilon naught r, where q is the charge on its surface and r is the radius of conductor.